Hello everyone, today we are going to dive into our first problem of the year, which is assign cookies. So in this problem we are going to go through the scenario that has been defined here to assign cookies to children. So we have a list of children with a number representing the intensity or the size of the cookies that will satisfy the student, and we have a list of cookies. And then now you are supposed to find out how to share those cookies in such a way that you are going to satisfy the biggest number possible of children. So basically that is what we are supposed to do here. How does it work? Let's say we have this example. We have an array of 3 children, 1 2 3. This is the size of the various children, and then we have here a size of 2 cookies. The first one is 1 and the second one is 1. These cookies can satisfy this first child, but after that these cookies will not satisfy no one. So at the end of the day we are going to have an output of 1, because with this input we can only satisfy 1 children. Let us take this one for instance. Here we have 2 children. This one can satisfy the first one, this one the second. We are able to satisfy both of them, so we are going to return 2. Now, given this input and then the scenario that has been described, how can we return the maximum number representing the children that we can satisfy, maximum number of children we can satisfy? Let us take this for instance to understand better. Let's say I have this for instance. I can say, okay, I will take this one. This is the children, the array of children, and this is the cookies. I can say this one go to this one. This is 1. I can say this one go to this one, because 5 can satisfy 2, so this is 2, and this one it will not satisfy anyone, so I will return 2 here, because I was able to satisfy 2. But this is actually a solution, but it's not actually the biggest solution we can have. Why? Because we choose 5 to satisfy these 2, whereas we could have choose these 2 to satisfy these 2 and choose this 5 to satisfy these 4. This kind of trigger in you a big question, which is, how can I organize myself? So this is the second one I was saying. This is the one. This one is going with this one, and this one is going with this one, and this one we give 3, and this is actually the solution. So now, given this, how can we organize ourselves to make sure we have the biggest possible number of children we can satisfy? So what we did is that we choose as if we were having a sort array. So we say, okay, the first one is going to the first one. Instead of saying this one is going to the second one, we didn't say that. We say, okay, which is the next smallest one? It was 2, and we just check, is this 2 actually able to satisfy anyone here? If it's the case, then it's a solution. If it's not the case, if the 2 cannot satisfy the smallest here, that means it cannot satisfy anyone. Is that clear? And then you move to the next one. So taking that in consideration, how are we going to solve our problem? To solve our problem, we are going to first sort both the first and the second array, and then we are going to loop through those elements. So this is here. We sort the first and the second array. Once we have it, we create a variable result, which is going to keep track of the number of children that we have satisfied already, and then we have the index pointing to the array of children, and the index pointing to the array of cookies. Now that we have those elements, we are just going to loop. After each iteration, we are going to move the array of cookies one step forward, but we are going to move the array of children only if we had a solution. That means for something like this, after sorting this, it's going to, let's say we have this array. So after sorting this, it's going to look like this. Let us take this and try to commit. So we are going to have the 2 that will come before the 5. After the sort, we are going to have the 2 here, we are going to have the 5 here, and then here is going to be the 5 that is going to take before the 4 that's going to take to come before the 6. So we are going to have the 4, the 6, and the 8. And then what will it look like? We are going to say, okay, since everything is now sorted, we are going to say the first one, is the first cookies able to satisfy the first children? Yes. So we just make yeah, and then they say yes. Is the second able to satisfy? Yes. Is the third able to satisfy? Yes. That's how we are going to loop. Let's say we are having maybe a number here that was not able to satisfy, in the sense of, let's say this is the array of children, this is the array of children, this is the array of cookies. Let's say we are having maybe 3 here. Let's say we're having 3 here. So if we were having 3 here, we were to act a little bit different in the solution. Like, okay, is the first one okay? Yes. Now is the second one okay? No, because 2 cannot satisfy 3. If 2 cannot satisfy 3, given that 3 is the smallest element in the rest of the children, that means this one will not satisfy anyone. So we can move to the next one, and we're going to check, is 4 now able to satisfy 3? Yes. That means those 2 are going to give the second solution, and this will actually return 2, which is actually our solution. So basically what we are trying to do here is, the idea is that if a cookies cannot satisfy the smallest cookies of this children, that means it cannot satisfy anyone, so we just move. If it can satisfy, then we both move the cookies and these children, and at the end of the day, you are going to have the maximum number of children that you can satisfy. So this is why we have the children being increment only if we have a valid solution, but in each of the steps we are always going to increment the index of cookies. So by doing so, we are able to have something that is working. Let us run and see what it gives. Nice, we have everything green. This was my approach of solving this. I hope you do enjoy it. Feel free to give me any feedback. I'll be really happy to interact with you regarding this. See you on the next video. Ciao.